Hello, everyone. Today I thought we might spend some fun on our day off solving log equations. Okay, this will correspond with the notes that I gave you in class, the type notes on solving log equations. But I thought we would just take a look at a few examples. The first example I have here, where I'm solving a log equation, has log base 3 of x minus 5 equaling log base 3 of 2x minus 16. Okay. Well, similar to with exponential equations, if you see that both sides of the equation have a log expression in each and a single log in each, and they both have the same base, which is 3 and 3, then the only way for the logs to be equal is for the arguments to be equal as well. So I can write the equation x minus 5 equals 2x minus 16. And in essence, since the logs are the same, we're ignoring those and just solving the arguments. Okay, solving for x, I would subtract the x across. I would get x on the right equals, adding the 16 over to this side, I would get x equals 11. All right. Now, unlike exponential equations, when you solve a log equation, because logs, we say, have a restricted domain, meaning that your argument, remember, cannot be 0 or negative, we need to make sure and plug this answer that we just got back into the original equation right here and right here into both arguments. The only thing we're trying to avoid is a negative or 0 argument. If I plug 11 into the first argument, 11 minus 5 is 6, that's positive, that's fine. Plugging in 11 to the next one, I get 22 minus 16. I really don't even care what the answer is as long as it's positive, which it is, and we're good to go. Okay? So since both answers, since 11 produces both positive arguments, I know that 11 works. Okay? Remember that if something doesn't work, even though I've done everything impeccably and there's no mistakes, if it doesn't work, that's called an extraneous solution. I don't write extraneous, it just means that it doesn't work, and we ignore it. All right, let's take a look at the next example that I have here. In example B, let's move the slide down a little bit. In example B, I've got this problem here. Okay? Now, here's where that skill that we did earlier this chapter comes into play. On this equation, I'm still solving for x, but if you notice, in this problem, I've got two different logs being added. Well, the only way that I can drop the logs is if I have a single log on the left and a single log on the right. Well, on the right I've got the single log, but on the left I've got two logs added. Well, don't forget that we learned in a previous section that if I have two logs added, I can condense those into a single log multiplied. This is log base 31 of, and I'm going to put a bracket for this argument, x plus 2 times x equals log base 31 of 15. All right, by condensing this left side, notice that I now have that single log situation, so I can basically ignore the log expression part of it and focus just on the arguments. By doing this, I create the equation x squared plus 2x equals 15. Solving for x, because this is quadratic, I need to start with a 0 on one of the sides, so I'm just going to subtract our little 15 across and get x squared plus 2x minus 15 equals 0. This quadratic's factorable, so I factor him into x plus 5 and x minus 3. And solving for 0 from here, I get x equals negative 5 and x equals 3. Again, notice that now when I plug negative 5 in, because don't forget with log equations I need to check for extraneous solutions. By plugging negative 5 into either one of these arguments, I'll produce a negative argument. So the negative 5, he does not work. Plugging the positive 3 into both arguments produces me an argument of 5 and 3. That one works, so that's my only answer to this equation. X equals 3. Okay, now let's take a look at some more varieties of problems here. Let's take a look at the next example that I've got over here. I'll drag him down, extend the page, and let's take a look at the next problem. Let's see a couple problems and then we'll call it a day. All right. So in the next problem, I've got a log equation where I have two logs subtracted. I also set it up so that if you notice, this 2 here, he's not part of the argument. Whenever you're solving log equations, you need to make sure and isolate your logs and move anything that's not part of the log to the other side. So in this problem, I'm going to do two things. I'm going to condense these two logs into a single log, but I'm also going to add the 2 to the right. When I condense on the left, I get log. Oh, wait a minute. When I subtract logs, don't forget that's a division, so it's going to be x over 3x plus 2. Oh, sorry, 5 equals 3. All right. Now, again, another reminder is that when you don't see a little base number down here, that we know that that base is a 10. So that's actually the common log. All right. Now, moving forward, the next issue in this problem is I only have a log on the left, but I don't have a log on the right. So I can't use that little nifty trick of just ignoring the logs and solving the arguments. So what do we do? Well, what you need to do in this problem is you need to, let's put the little 10 there just as a reminder, it's base 10. You need to rewrite this in exponential form. Watch what happens when this does this. When I create this in exponential form, I get 10 to the third power equals x over 3x plus 5. Now, solving for x from here, notice I've just got regular x's out of arguments and they're not in exponents. I can now solve back for x. I get 1,000 equals x over 3x plus 5. Cross multiplying, I would get 3,000x plus 5,000 equals x. From here, I would get 5,000 equals negative 2,999x. Dividing both sides by the coefficient, I get 5,000 over 299 in a negative fashion. So I get x equals negative 5,000 over 2,999. Or in other words, if you think about it, a little less than 2. Now, when I plug that negative number in, notice in this problem I would get that negative log again, that negative argument. So after all that work is said and done, unfortunately, we cross him out, and the final answer is no solution. Okay, last example for the day. Let's go with example D here. Let's let him down. And let's look at what's going on here. I've got another problem where I only have the single log here. Now, doing this problem, I have 4 times the log base 25 of x minus 3 equals negative 2. All right, again, I don't have to condense on this side. There's only a single log. But because there is only a single log in here, I can't drop the logs. Therefore, I need to isolate my log expression. The log expression will start with the word log and end with the argument of x minus 3. That means I need to divide both sides by 4 to isolate him. By doing this, I get log base 25 of x minus 3 equals negative 1/2. By isolating the log, I can now write this equation in exponential form. This would say 25 to the negative 1/2 power equals x minus 3. Now, what does the negative do to this base? Well, it takes the reciprocal of that. And then the half power is here. Now, don't forget that the half power means that you need to square root both sides of the problem. So when I square root the top, I get square root of 1 is 1, and square root of 25 is 5. So 1/5 equals x minus 3. Simply adding the 3 across, I get x equals 3 and 1/5. Checking for extraneous, if I plug 3 and 1/5 in for this argument here, 3 and 1/5 minus 3 is still just 1/5, which is okay. I just need to avoid zeros and negatives. Since that's okay, the final answer is 3 1/5. Or in algebra, we like our improper fractions of 16/5. Well, unfortunately, that's all I have time for today. I know you wanted more, and we will see you tomorrow.